In my series of recordings in which I sketch the graphs of polynomials, up to now I have dealt only with quadratic functions that give parabolas as their graphs. This recording is the first one in which I will look at a cubic function. I'm going to keep it simple to begin with, and so we'll look at the cubic shown here. The first thing I want to do is to remind you what the graph of just y equals x cubed by itself looks like. I hope you remember that it comes up from far down to the left, flattens out, passes through the origin completely flat, and then heads on up to the far right. But now, look at the function that we really want to sketch, y equals x plus 1 cubed minus 2. The addition of the 1 to the x here is simply a shift to the left by a distance 1 on the basic function y equals x cubed. So we could delete the graph that we have here and instead move it over so that the flat part hits the axis at x equals negative 1. Let's do that. Here it is. It's just our first graph, now shifted to the left by 1 unit. But notice that there is now another interesting point to mark on. That's the y-intercept. The y-intercept happens when x is 0. Substituting x equals 0 into the formula gives us 0 plus 1 all cubed, which is just 1. Let's mark that on. We're nearly there now. We've just got to take into account that negative 2. But the negative 2, of course, is just a shift for y. It shifts the whole graph downwards by 2 units. So the flat part of the graph now will have coordinate negative 1 for x, but negative 2 for y. It'll move down by 2 units. Let's erase this graph and move it down. It must look like this, mustn't it? But notice now we've got 2 further points to calculate, the 2 intercepts. When x is 0 in this formula, y is 1 cubed minus 2. That simplifies to negative 1, so that's where we hit the y-axis. What about the x-intercept? For the x-intercept, we need to solve y equals 0. Notice the different way those two conditions are written. For the y-intercept that we've already got, we set 0 in the function y. That's y of 0, written in black here. For the x-intercept, we have to set y equal to 0. We'll need to take the y equals x plus 1 cubed minus 2 and set that equal to 0 and try to solve for x. It's not hard. We just need to move the 2 to the other side of the equation and then take cube roots and then adjust the whole equation again by shifting the 1 to the other side. Here's the first step. Then the second. Remember, the 1/3 power means the cube root. And then finally subtract the 1 to get x equals the cube root of 2 minus 1. I don't know the exact value, and I don't have a calculator at hand, but I do know that 2 to the 1/3 is a little bit more than 1, so that this value will be just a little bit more than 0, but less than 1. You can get the approximate value from a calculator if you wish. I consider that I've now finished drawing this graph, so I'm going to stop.